This lesson is over the lens equation. So I'm going to go back a lesson here. If we know the focal length, this distance is called f, the focal length. Every lens, every converging lens um, has one set focal length, like it's made that way. And depending on where we place the object, because we can vary where we place the object, whoops, I wrote over f. The distance from the object to the lens is called dO, the distance to the object. And if we know just those two numbers, we can figure out the distance from the lens to the image, which we will call DI. Okay. Two other quantities we can know is the height of the object. It's basically how tall it is. And we can know the height of the image, which we call HI. And we called this one HO. So that's what those various distances we're going to use today are called. And that's how we label them. Now, much less messy is our notes, which has everything written here. So it's all here in the notes. These are the equations we're going to use, and I'm just going to jump right into an example. This one is called the lens equation. 1 over di plus 1 over do is equal to 1 over f. And then we have two magnification equations, which will help us answer some more questions. The only thing I want you to know about this equation, the lens equation, is that this is an inverse equation. So if I take 5, I'm just giving you an example, and I take the inverse of 5, that just means 1 over 5. That's the inverse of it. If I take the inverse of 1 over 5, it's 5 again. Okay. And so hopefully you know what inverses are, but if you don't, that's just a kind of a quick explanation of what an inverse is. So this is the inverse of di, this is the inverse of do, and that's the inverse of f. Let's go jump right into an example. Here, we're given a lens with a known focal length of 4 centimeters. The object is placed, because we can put the object anywhere, it's placed 12 centimeters from the lens. And the height of this object, how tall it is 3 centimeters. We want to figure out precisely where the image is going to be located back here, such that if we put a screen at this place back here, we will actually get a focused image of, this arrow, whatever that is. So for part A, we're going to solve this using the lens equation. We always go in this order. Whoops. This is 1 over di plus 1 over do is 1 over f. Plug in what you know. We're looking for di, so we're not going to be able to plug in anything there. Not equals, but plus. We know do is 12. And we know that the focal point is 4 centimeters from the lens. That's this distance here. Well, as we usually want to do, we want to isolate the variable. That's di. And we don't have di, we have 1 over di, which will be good enough. And to do that, we're going to subtract 1 over 12 from both sides of the equation. Minus 1 over 12 here, which cancels it. And I should write it if I'm going to do that. And then minus 1 over 12 over here. So I kind of regret showing that now. So let's just move this down here. But, we do that here, we must write it over here as well. So I'll say 1 over 4 minus 1 over 12. The last step is I want it to say di equals not 1 over di. So like our example earlier, we're going to take the inverse of this. And this is how you take the inverse. You put it to the -1 power. Um, and if we do it to that side, we must do it to this side. We'll take the inverse of that. So we'll just type this in the calculator, make use of your fraction button. There is a fast way to type this in the calculator, so you can come see me about that if you want to know how. But this should come out to 6 centimeters, and you should practice that and try it out. Now, the next thing we want to know, part B, is what is the magnification of the image? So is the image going to be bigger than the object, or is it going to be smaller than the object? This is the equation we will use. If there's a negative in this equation, so you must keep that negative in there. di was 6 and do is 12. We always want a decimal. Don't forget about the negative. There are no units for m. The magnification is negative 0.5, there's no units. And the 0.5 means that it will be a reduced image. The negative means something else. We'll now find the height of the image. How tall will the image be? We'll say m equals hi over ho. We'll plug in negative 0.5. We'll plug in, so we don't know hi, we'll plug in ho, which was given up here as 3 centimeters. And to solve this, we'll multiply both sides by 3. I should do it like that. Actually, this is negative 1.5 centimeters is the height of the image. Now, let's think about this. The object is 3 centimeters tall, the image is 1.5 centimeters tall, so it is in fact reduced. The negative, many people guess this correctly, means that it is inverted. It is an upside down image. Inverted is the correct answer there. Cool. Sorry for the quick video. Um, Come see me if you have questions on this one. I have 2 minutes. I'm going to explain this real quick. Okay. If the absolute value of m is greater than 1, then the image is enlarged. Otherwise, it is reduced. If hi is negative, the image is inverted. Otherwise, it is upright. And I think next year, I'm going to change this, but O means object. I means image. Oops. It's actually just faster if I write it. This is focal. Cool. Not all of them are in centimeters. It's kind of like a typo. M has no units, but the rest of them, they're typically in centimeters.